Hi, and welcome to this quick tool review. This time around we are not taking a look at this drill. This is one I reviewed in the past. It's actually, what I'm going to be looking at is a newer version that is hopefully improved from this version. There was a fair amount of run out in the shaft on this one, in the spindle. The wiring was not great in this one, and I had to adjust the columns so that it would go up and down smoothly. Vevor has kindly sent me a newer model to evaluate, and I want to do that today just to see how they are improving. Obviously, I don't need another magnetic drill, but I thought it would be good for you if I checked it out, so in case you were in the market, I could potentially give you some useful tips. So the model we'll be looking at today, I believe, without opening up, is a 1400 watt 2-inch boring capacity 2922 foot-pound power magnetic drill, 810 RPM, 10 speed, 1 second release drill arbor, electronic drilling machine for metal surface and home improvement. I was attracted to this only because they seem to be getting better and better quality, and I wanted to see if that was actually true. Just for a little bit of history, I thought this was interesting. I was looking up magnetic drills, figuring they would have been invented, 10, 15, 20 years ago, something like that, 30 years ago. But here's the interesting history. So the original drill, electric drill motor, was made in 1889 by Arthur Arnault and William Bryan. And that unit was so big that it had to be sort of crane lifted onto construction sites. It was not by any stretch importable. I haven't seen a picture of it, so I don't know exactly what it weighs, but that's what the article talks about. Then in 1895, Fine came out with the electric hand drill, which I had no idea was that old, 1895. I don't think most people had electricity in 1895, but maybe I'm wrong there too. 1909, Fine also invented the mag drill. So this is a long distant relative of the Fine mag drills, which they still make today, incidentally. And if you know anything about Fine, they are extremely high quality European made tools, and they cost it. So this lists for $459 on Amazon. So let's just open it up and take a look. I also wanted to note that we got a nice wooden bottom on this packaging, and they put additional corner protectors on every corner of this package. This is one of the best packaging jobs I've seen to date. I'm very impressed with it. All right, so the lid pops off just by going around the tape on the edges, and the walls are, I don't know, it's single layer thick, but this would be like 4 times thicker than regular cardboard. So again, very impressed with the packaging. This set comes with 6 annular cutters. 6 annular cutters all by themselves are probably around 80 to 100 bucks for that's an impressive inclusion all by itself. Comes with a coolant bottle that it seems like it's a lot better made than the last one. Well protected. The last coolant bottle was completely rickety. I would dare say almost to the point of uselessness. This one looks like it's got a solid cap and a nice valve on the bottom. Oh, that's very nice actually, with a good mount. Wow. That is a definite improvement already. Looks like it's got a 1/4 inch quick connect. That's an interesting piece. T3/4 to 1/2 inch 20 UNF. I'm kind of curious about what this goes to. This must be something about attaching the drill chuck. What an interesting arbor, because that was included in the package with the drill chuck, which also is typically costs extra. My last one had to pay extra for that. Yeah, that's what it is. So you can use regular drill bits in this guy. See right off the bat, this one feels lighter than the last one, yet its capacity, I believe, is more. Or at least the same, but it might be more. Looks like it comes with all the tools you need for assembly. Because these handles stick out so much, I tend to store mine without the handles on. Oh, there we go. It's an odd angle, so it doesn't want to start if you try and go somewhat straight up and down. So the column adjustment up and down is much, much smoother than the last one. I'm trying to do this one-handed here, but yeah, this is very smooth. It doesn't feel like any adjustment is needed. Still has aluminum on aluminum track. which, you know, if this was an everyday user, it's going to get worn. At least the rack is steel, at least by the look of it. On the other side, we have 2 thumb screws for mounting the coolant tank, it looks like. It's nice that they made it easy to remove. Thumb screws are a nice touch because this thing gets kind of bulky to store if you include all that stuff. So it's interesting. With these handles, they kind of block button access here. The on and off, kind of in the way. That's an interesting location for it. I'm not sure what the other guys do. You can get to the forward and reverse and off switch, but the main on-off is kind of blocked, and the mag on-off is also a little bit blocked, not as badly as this one. The main breaker on-off, the one that seems like a magnetic switch, but I don't think it is blocked, and then the speed control is pretty reasonably accessible as well. So interesting, of all the things it includes, what it doesn't seem to include is hose for the coolant tank. It's got the 1/8 inch, the 1/4 inch hose quick connect, and it's got a 1/4 inch quick connect on the side of the drill motor, but no hose. Oh, never mind, incorrect. It's in with the manual. They did think of everything, that's great. And that could just go here to here. On this side, it's somewhat stiff, feels like vinyl tubing, but this is removable, so you can store it separately. So this adapter is for the 1/2 inch drill chuck, standard threads. Not the smoothest drill chuck you've ever felt in your life, but it is included free of charge. I mean, the action is smooth, as you can just hear it, that the machining here is kind of rough, and so you can hear it as it goes. It does feel reasonable as you're doing it, so that's not bad. So the bit quick release has a pretty hefty spring, but it does engage reasonably well. Once you get it set, it's in there. No problem there. Alrighty. I'm going to take a look at the manual, see if there's anything obvious I missed, but it seems like pretty straightforward. So the manual that comes with this guy is surprisingly good, and they're keeping up with us here in the States here, because fully the first half of the manual is all safety warnings, just for the lawyers. It's this model here, the 8850E, so it does from 3 millimeter to 16 millimeter, which is just under 1/4 inch to a little over 1/2 inch, maybe 5/8 of an inch drill bits. It does tapping 3 to 14 millimeter. M14 is a little bit over 1/2 inch, sort of an M12 is around a 1/2 inch bolt size. 13,000 Newton traction for the magnet, supposedly. Oh, it can drill 50 millimeters, about 2 inches deep. Speed is 0 to 810 RPM. And the travel is something like 8 inches, I'm guessing. 25, if it was 254, that would make it 10 inches. So it's like 8.5 inches kind of thing. 1400 watt motor, 15 amp fuse, forward and reverse, so it's reversible. That's nice, especially for tapping. And the manual's surprisingly readable. Also, look at that, an exploded parts diagram. You don't get that in a lot of Asian stuff, so that's really, especially a legible one. This is very handy with a breakdown of all the parts. Oh, they're stepping it up. This is much, much better than the model I had that I just showed you the quick blurb of. All right, let's power this guy on and see if we can take a cut. For the test here, I'm choosing the largest annular cutter that comes with this guy. It can do 1 inch depth and it's 27 millimeters. Very, very sharp, finely ground, impressive quality. That's a 1 inch depth of cut. To give you perspective, here is a 2 inch depth of cut. It does not come with this one, but you can see that the core is significantly more, and this thing can handle 2 inch cuts. And you can tell the limitation would be how far, among other things besides motor power, would be how much does the drill bit extend underneath the unit itself. Because if it doesn't fit, you're gonna have a hard time cutting when the magnet is engaged. All right, so we have the unit just sitting on top of the stage weight here, which is either cast iron or steel. This one's probably cast iron. See if I engage the magnet, it is on there. By the way, the magnet strength depends not only on the electromagnet strength itself, but how thick the material is. If you put it on thinner material, it's not going to hold very well. And that's because the magnetic field saturates the thin material and then the rest of the magnetic leaks out. So it doesn't matter how strong a magnetic field it's got. All right, so here we are with the electromagnet, and I'm cranking on this rack and pinion here, pushing this down into the column. And you can see that with this thick of metal, it doesn't move anywhere. Turn off the electromagnet. Let's try it on this thin sheet metal here. Still pretty darn good, but not full strength, and that's what they're talking about. I can feel, yeah, see? I was able to break it loose. I guarantee you I couldn't break it loose from this chunk of steel. We're going to go for minimum speed here. That was interesting. It bogged down and stopped. Yeah. So you can bog this motor down. This is cast iron I'm cutting into, so I shouldn't need lubrication. I'm kind of wondering if I'm got this in an outlet that can't supply enough current. That is really weird. All right, so I'm going to go get a different power source. I've got 20 amp circuits here in the garage, but you could see that was bogging down and actually stalling. So it is the largest, I don't think it's actually the largest capacity that this thing can handle. Let's see, hole diameter 50 millimeter. No, it's not that. This is only 27 millimeter. So it should be able to handle it, but it sure wasn't. All right, so I've got this thing wired now to a direct 20 amp circuit, just in case the extension cord that was pretty light gauge that I was running this off of couldn't hack it. Oh yeah. Oh, big difference. Although I can stall the motor, yep. There we go. So I'm thinking that there was a hardened crust on this, and that because it went really easily after it got through the hardened crust. But I really was surprised that I could actually stall the motor by pressing into it, although it got much better when I went to a direct 20 amp circuit. It says it'll work on 15 amp circuit. I had it on a really light 18 gauge extension cord that had a couple other things plugged into it. So the combination of the electromagnet and the motor running may have been too much for it, but it did make quick work of this. I went the full inch in. This is thicker than that. Let me slide this back and vacuum this out for you. I don't know if you can see this very easily. I'm zoomed way in here, but other than where it slipped initially when it stalled the motor, which probably reduced the amount of current because there wasn't enough current, so the electromagnet probably got a little weak. Once I got past that point, the cut is very, very clean inside. So you can see this little ridge here. That's just the first 1/8 of an inch, 1/16 of an inch. The rest is very smooth wall. So it did an excellent cut, which kind of says that the run out is probably not too terrible. All right, next up, what I didn't try was higher speed cutting, because maybe this thing doesn't produce full torque at low speed because they're reducing the current to the motor. So when you go faster, it's actually producing more torque. The only problem with that is that you don't usually use annular cutters at really high speed like that. So that's kind of weird. It may damage the cutter, and I hate to ruin the cutter because the cutters are actually very nice. All right, so I'm going to crank this guy up to half speed. I went to smaller annular cutter because I'm going faster. And it makes me feel really uncomfortable using a big cutter going fast. Doesn't make any sense to me. That's half speed. Much better. And that was half speed. All right, let's try full speed. This seems ill-advised. Yeah, you can bog it down, but it's got a lot more power. A lot more power. See if you can see how good that hole is. That is a beautifully clean hole that it cut. Pretty fantastic, actually. Smooth sidewalls. Same with this one on the second cut. And it cut a very nice clean hole. So maybe you can use these much faster, and then when you're using them faster, maybe then you have to use cooling, even if it's cast iron, where the graphite in the cast iron acts like a lubricant. But maybe you need it for cooling, although the cutter's not terribly warm, so that's a big plus. You get a lot more power when you speed this guy up. I know some of you were thinking, I want to see apples and apples, so here I am back at the 27mm cutter again, and we're going to try and cut at high speed. A lot more power. So the motor didn't overheat and didn't bog down too much. It bogged down a little bit, you could hear, but I was really cranking on it to get the feed going in. So there's the trick. You can't really use the low speed mode on this drill unless you're going to go very, very lightly with the quill pressure. If you want to cut normally, what I would consider normal anyways, you got to run it fast, which means then maybe coolant would be necessary. Notice how clean this hole is. Very, very clean sides. By the way, I think they're very proud of the quick release because it was listed in the manual as a feature. This very small turn here, it takes a reasonable amount of pressure, but the quick release feature, it really does work well for getting the bits in and out. And just looking at the cutter, it doesn't look like it took too much damage, or any damage for that matter. So that's a good sign. I was worried it was going to chip running that fast, but it's actually fine. These are very nice cutters that it came with. All right, so here's the unit off. Here's electromagnet only, about 1.25 amps. Here is motor on slow. Startup current's high, about 2.5 amps once it gets going. And there's current full speed, no load, 4.6. So my guess, under full load, this thing probably comes pretty close to the 15 amps, especially if you're going low speed. So it does put out more current when it goes faster, which, you know, generally require more current to go faster. So it sort of makes sense unless they're pulse width modulating, which I don't know that they are, and I have to get a scope on it to tell. But interesting observation, because the torque definitely seems to be much better under high speed. You can really crank on that quill, and get really fast cutting. So that's a plus. It's unfortunate you can't do the slow speed unless you're going to be very gentle on the quill. Yeah, I don't know how easy this is for you to see, but there is a bit of run out on this. It's about 5 thousandths. Yeah, about 5 thousandths of run out on the shaft here. Now, assuming that the inside isn't better, that's quite a bit of run out for a spindle, although I don't have experience to compare. I mean, obviously if it was a lathe or something, that would be horrible, but I don't know what to expect for this. Let me see if I can find something else to measure off of. And this is now looking at the inside of the shaft on the surface where it mates, and that's about 4 thousandths as well. So that's a little more than I'd like to see. Popping this guy in reverse, it's a little bit slower than it is in forward. That's forward, leaving the speed alone. That's reverse. So it's slower in reverse than it is in forward. All right, here's another interesting observation. So I've got this all the way up, and I put a stubby drill bit in there with the drill chuck, and it's all the way back. But you can see that you can't even put a stubby drill bit, at least a 1/2 inch in here. So you're probably not going to be using this for much if you're using the mag base to hold this down. So that's not ideal. So next I'm going to pop this guy open just to see what the electrics look like. So note that this is a master on-off. It's supposed to be like a magnetic switch. I don't think it is a magnetic switch. And magnetic switch, basically the point of using one is that when you hit it on, a magnet holds it in place and continues to keep it on. If the power were to fail, then the magnet would release and you'd have to reset it, so that if you were drilling something, power failed, and you went to go and investigate the power failure and came back and then restored the power, the drill wouldn't suddenly, or the piece of machinery wouldn't come on its own, which would be very dangerous. So that's what magnetic switches are used for, in case you didn't know. This I don't think is one of those. So they're at least machine screws, so that's a plus. It's drilled and tapped. It's funny, the forward and reverse, I'm guessing L means forward because it was forward. Also it says positive over here, and R is reverse or anti over here, so that's kind of interesting. So here's the wiring. It's moderately neat. There is a speed control board down below that also looks reasonably neat. I can tell you that having an electromagnet on for that period of time, it got warm. Not overly hot, but warm. And this is not a magnetic switch. It is just a regular on-off switch. So basically an overall off-on, but then you can't turn on the drill motor until the magnet is on. So that's kind of silly. That sort of becomes the overall off-on as well. You got a speed control board and then the magnet board, which they have, you know, a full wave bridge to make DC. The wiring is fairly neat. Certainly not the best wiring I've ever seen, but completely serviceable. Maybe you can see that. So speed control right here, and then the main circuit board's down here with the magnet, basically full wave bridge, because you want to feed DC to the magnet. And a couple other components, looks like some surge protection and stuff, but that's about it. The wiring is okay, but you wouldn't expect something great for the price point of this, because I think without the annular cutters, this guy's in the $200 and something range. All right, so what are my thoughts overall? Well, there's some definite improvements, some major improvements actually. The column is much smoother than the last one, and it required no adjustment upon arrival like the last one, which the last one bound up in several spots. So I had to loosen it and then sort of tighten one and sort of tweak it a little and tighten the next one, and et cetera, in order to get it to run smoothly. This one runs smoothly right off the gate. The handles, the screw mounts for the handles could have been used a little bit of thread chasing. They're pretty rough. I got all the handles started, and for me, I don't store it with the handles only because it makes the whole package a lot smaller to store, and I've got very short on space. I don't know what other people do, so if you leave them on, once you get them on, you're never going to take them off, then it's perfectly fine. The on-off switch is bizarre to me. I think it's designed to look like a magnetic switch for safety, but it is not a magnetic switch. This is just a plain off-on switch. You can't turn on the drill without the magnet on, so you are only using this in mag mode, which makes sense because it doesn't really have any clamping options on the base. So that's probably fine. The speed control is smooth. It's fine at high speeds, although I don't know if at high speeds you have more torque because this thing is controlling current. I'm not sure what the speed controller is doing with this guy, so maybe it would have cut better. I'm a little concerned that I was able to stall the motor in a 27mm annular cutter because it's supposed to be good up to 550, so that's almost double that size. So that'd be a lot more force on this. I was running at the slowest speed, which you think would be its best mechanical advantage, but maybe the way the controller works, it wasn't giving maximum current to it, so it couldn't operate at its highest torque. I don't know that. The on-off switch is very fine and solid. The wiring is reasonable. A much improved coolant cup if you use coolant. I was cutting into cast iron. You don't need coolant for cast iron. The carbide in the cast iron acts as a lubricant on its own. The annular cutters are very high quality that it comes with. It comes with one centering shaft. It comes with a 1/2-inch drill chuck, although even my 1/2-inch stub drill would not fit in it with the magnet on it. So unless you space this up somehow, or you're not mounting this to the thing you're cutting, meaning you've got like some sort of step that you can put the drill on and then you're cutting something beneath that, you're not fitting too many drill bits in here. So that's sort of a nice but useless option, at least as far as I can see. The manual is very nice quality, and it's a nice additional plus that it came with all the Allen keys and tools needed to work on this thing. So I was looking at the manual a little more closely, and it did mention that you need to take it very slow when you're starting out so that you don't stall the motor potentially. It also says that after about 2.5 hours of work, you need to give this guy a rest because it could overheat. If you hit overcurrent, you need to shut it off immediately so that the overcurrent protection, over temperature protection, can reset if it trips, and if it doesn't trip, give it a chance to cool off so that it doesn't trip. It also says that the magnet requires at least 15mm of material, which is a little over a 1/2 inch, in order to get full strength. So all those things should be taken into consideration. The unit is far more polished than previous units I have looked at, and so I'm going to give it a thumb sideways. I think it could use a more powerful motor. That would be handy. But maybe they can't do that with a 15-amp circuit, or maybe if I had compared it directly to, say, a Fine or a DeWalt or Milwaukee or a Hugin, I changed my mind. But for the price, those other units are about $2,000 in the same size arena. So there is a bit of a price difference here because this unit without the cutters is something like under $300, I believe, and $450 gets you a whole, $460 gets you a set of cutters as well. So not a bad deal. Thanks for watching. Hope you find it useful. Hope to see you next time.